Hi everybody, this is the Math 10C Exponents and Radicals review, and this is the short answer, number 1. And I'm going to do all three of them. I'm going to do, because these are pretty quick here, so I'm just going to do A, B, C all together here. Find the prime factorization of each of the following. Okay, so with 300 here, when I take a look at 300, initially I see this as 3 times 100. There are a couple of different ways you can do this, and I'll show you another method with B here. But if I just take a look at that, I just see 3 times 100. I just yank those 2 zeros away here. So this is going to be 3 times, and then 100 I know is 10 times 10. And then 10 is 2 times 5. And this 10 is 2 times 5 as well. And so there's my prime factorization, but I'm going to write it in order. And so this is going to be 2 squared, because there's 2 of them there, times a 3 times 5 squared. Okay, so there's the prime factorization of 300. Now I might do that a little differently with 735. What I might do with 735 is, first of all, I'm going to divide out 2. This is 735 divisible by 2. The answer is no. I get 67.5. So the 0.5, no. So now I just increase what I divide by. I'm going to divide by 3. Can I do that? Yes, I can. So when in fact, I'll show you on my calculator. I should probably let you see this here. So I've got 735 divided by 3 is 245. So I know that it's divisible by at least 1 3. So let's try that again. Is that divisible by 3? No, that's not. Okay, so the 245 isn't divisible by 3. So now I take the 245 that I got, okay, and I'm going to divide by 5. Okay, I can do that. So that's divisible by 5. And now, now that you look at the number here, 49, I think it's pretty clear that my other remaining factors are going to be 7 and 7. So this will be times 7 times 7. Or I might write this as, whoops, sorry, it's a horrible 3. I might write this as 3 times 5 times 7 squared. Okay, now let's take a quick look at this last one. Sorry, make sure everything's together here. 234,650. Okay, well, now here's a big one. That's a big number here. So that procedure that I just started here, that might not be a bad one here. So what have we got here? This is 234,650. Okay, so first thing that I'm going to do here is divide this by 2. Can I do that? Yep. So this is going to be divisible by 2. Oops, sorry, you can't see what I'm doing there. Now, I take it, look what's left over here. Notice this is no longer even, so this is not divisible by 2. So let's try 3. Can I divide that by 3? No. So I got to go back to 117,325. I'm going to divide by the next prime. The next prime is 5, and I know this is divisible by 5. So I know that I can come back here and say, okay, that's divisible by 5. But the other question is, how many 5s? Because this answer is also divisible by, whoops, sorry, not 6, by 5. But notice that this one isn't. 4,693, that is not divisible by 5. Okay, so I only had 2 factors of 5 that came out of that. And so now, when I take a look at this number, I'm going to divide the 4,693 by the next prime number, which in this case is 7. Okay, well that doesn't work. So 4,693, not divisible by 7. I move up to my next prime number. My next prime number is 11. Nope, not divisible by 11, so 4,693. Think about my next prime number. Next prime number is 13. Ah, it's divisible by 13. Okay, good. So we're going to multiply it by 13 here. Now the question is, how many 13s? So we got 361. Is that divisible by 13? Nope, it's not. So 361, we're going to divide that by the next prime number. And after 13, the next prime number is 17. Nope, not divisible by that. So 361 divided by, what's the next prime number? 19. And we get 19, and there's our end. Okay, there was 2 19s in there, so it becomes 2 times 5 squared times 13 times 19 squared. Now, that is again a little bit of a longer process there, but you see the systematic approach. You just start with the first prime number and you work your way up until you get the final smallest prime number as a result.